Now let us learn Newton's second law of motion, which says the rate of change of momentum of a body is directly proportional to the impressed force and takes place in the direction of the force. Let us say a body of mass m is moving with a velocity v. Okay, then the momentum is given by mv. This we have just learned, right? Now what it says is the rate of change of a momentum, that is, and the rate of change of a momentum of a body is directly proportional to the impressed force. Let us say this is caused because of acting of a force F. Okay. Now when the force is acted, it has started moving with the velocity v, but this velocity may be changing, right? Okay, see what it is saying. If I write in mathematical form, F is directly proportional to the rate of change of d by dt of momentum, right? So what I can say, F is directly proportional to d by dt of mv. Now m is a constant term, mass is a constant term, I can take out, implies that F is directly proportional to m d by dt of a v. Now dv by dt isn't it the acceleration? Acceleration is the rate of change of velocity. So implies that F is directly proportional to ma. If one variable is directly proportional to another variable, we can write the left hand side's variable is equal to some proportionality constant ma. Now we can choose the unit of force in such a way that k becomes 1. Then F will be equal to ma. How we can choose? Now let m is equal to 1 kg and a is equal to 1 meter per second square. Then F will be equal to 1 into 1 and F will be equal to k. Now if we will assume that we will call 1 unit of force is the force required to move 1 kg body with an acceleration of 1 meter per second square. If we define the unit of force in such a way, if we define 1 unit of force as the force required to move a mass of, to move a unit mass with unit acceleration, If we define 1 unit of force as the force required to move a unit mass with unit acceleration, then k simply is equal to 1, right? From here I am saying, therefore F is equal to ma, right? So the force, impressed force, is equal to mass of the body multiplied by the acceleration of the body, and this is the mathematical form of Newton's second law of motion. Now again, in the case of a special theory for relativity, when the velocity of the body is comparable with the speed of light, in that case again F is equal to ma doesn't hold good. F is equal to ma is no more good. Again, because the mass in a relativistic case, mass is a variable, and again that rest mass concept comes, right? Mass is equal to m naught divided by root under 1 minus v square upon c square, we just learned. So but this definition will always hold good. F is equal to, see, this is what, d by dt of p, or the rate of change of momentum. This will always hold good. Now actually Newton's second law of motion says this only, right? From that we concluded that F is equal to ma. But Newton's second law, I have erased that thing, I had written that, right? It is not saying that F will be the product of a mass and the acceleration. It is not saying that way. It is saying that the rate of change of a momentum will be directly proportional to the impressed force. So this only it is saying, and in the special theory of relativity, whenever we are applying, this is correct, but F is equal to ma will work, no more work, because m is not no more m when velocity becomes comparable with the c. It's clear? Now we will be seeing the dimension in the unit of force. What is the dimension? From the very fundamental definition we see F is equal to ma. So dimension of force is equal to, what is the dimension of a mass? M, and A, meter per second square, right? L T minus 2. So together what we can write, this is MLT minus 2. This is the dimension, which is simpler. Now what is the unit of force? There are two units of force. One is absolute unit, one is a gravitational unit. One is absolute unit and one is a gravitational unit. What are they? I am going to explain. See, both are coming from F is equal to ma only. Now, the force required to move unit mass with unit acceleration is called unit of a force. Then, what we will say, this is 1 kg multiplied by unit acceleration means 1 meter per second square. 1 meter per second square. If we will say, this is equal to 1 kg meter per second square. 1 kg meter per second square. Instead of saying again and again kg meter per second square, kg meter per second square, 1 kg meter per second square is also called 1 Newton. Honoring the name of the scientist, honoring the scientist named Newton. So it's called 1 Newton. So the absolute unit is Newton or 1 kg meter per second square in SI system of units. And see, the force, the unit of force, the absolute unit of force is unit mass with 1 unit acceleration. So this kg meter per second square we took in SI units. Now if I take CGS units, it will be 1 gram multiplied by 1 cm per second square. So 1 gram cm per second square is called 1 dyne. Okay. So Newton in SI system and dyne in CGS system. While teaching the theory, I am saying all these things, but Newton only we are going to use. And what is the relationship between them? 1 Newton is equal to 1 kg meter per second square. So if kg I convert to gram, 1000 grams multiplied by meter. If I make that a centimeter, 100 cm divided by, this is second square only. So these many grams cm per second square. 1 Newton was 1 kg meter per second square, or it is 10 to the power 5 grams cm per second square. That's a dyne. So the relation is 1 Newton is equal to 10 to the power 5 dynes. Now what is the gravitational unit? Now the gravitational unit is with what force a unit mass is being attracted by earth with respect to gravity. If unit mass, with what force it is attracted by earth, that is called gravitational unit, and that is 1 kg weight it is written, or 1 kg force. That means with what force 1 kg mass is being pulled by earth. Okay, So the weight of 1 kg, if it is 1 kg, what is the weight rate? Now assuming that g is a 9.8 meter, or let us say g is equal to 10 meter per second square, then if it's 1 kg you are taking, it will be attracted with 1 into g, that is 10 Newton force. That 10 Newton force, we can call it as 1 kg weight or 1 kg force. Okay, and again this is again SI system, and if we take CGS system, with what force 1 gram is being pulled by earth, we will see that. So 1 gram weight or 1 gram force will be the gravitational unit in a CGS system, and 1 kg weight or 1 kgf is the gravitational unit in the SI system. Now again, what's the relationship between them? 1 kg weight is equal to 1000 gram weight, right? So if we assume g is equal to 9.8 meter per second square, if we assume acceleration due to gravity is equal to 9.8 meter per second square, 1 kg weight is equal to how much? 1 kg multiplied by 9.8 units, so it is 9.8 Newton. And 1 gram weight is equal to how much? In CGS system, g is equal to 980 cm per second square. So 1 gram, this is 980 dyne. Clear? Now we will take up a few random examples. Let us take up this example in form of a question. In the question, 2 graphs has been given. One body is moving. Okay, a body is moving in a certain direction along its x component. What is the motion along x-axis that is shown? What is the motion along x-axis that is shown in this graph? And what's the motion along y-axis that is shown on this axis, this graph? Now, with what time, what is the displacement it is showing? Now, the question is, figure shows xt and yt diagram of a particle moving in xy directions. If the particle has a mass of 500 gram, find the force, direction and magnitude. Of course, force is a vector quantity, so it's having one direction and magnitude. We have to find out acting on the particle. What is the force, direction and magnitude? Now see, with simple analysis we can find out that here in along x-axis, it is a straight line, right? It's a linearly varying with time 3, x3, time 4, x4, whatever, it's a linearly varying. That means x is changing with a particular rate, and if we find out the rate of displacement, the rate of change of a displacement, isn't that a velocity? So velocity is equal to dx by dt, that is the slope. Is a red visible? Velocity is equal to dx by dt, that is the slope, which is equal to, which is a constant, since this is a straight line, which is a constant. If velocity is equal to constant, implies that acceleration must be 0, yes or no? Because acceleration is the rate of change of velocity. If velocity changes, then only acceleration comes into picture. Now velocity is constant, that means it is not changing, that is acceleration is 0. And we have studied that f is equal to ma. And if a is equal to 0, implies that a force also is equal to 0, and this is along x-axis, so force along x-axis is equal to 0. We can conclude it from this graph only, right? So force cannot be along x-axis. So this is a multiple choice question, so this is not correct. Something along x-axis, something along x-axis, these two are not correct, but these two are along y-axis. Let us see. Along y-axis, yes, it is velocity is varying, right? So acceleration is there. How to calculate that acceleration? Apply s is equal to ut plus half at square along y-axis. So what we can put implies that it is starting from rest, right? 0. So 0t, this side becomes 0 plus half of. Now s, let us think at the end, s distance is 4 meter or whatever. So 4 is equal to, it is starting from 0, 0 multiplied by t is 0, half a, how much distance in what time this 4 happened? In 2 seconds it happened, right? A t square, so 2 multiplied by 2, 1 2 got with 1 2, so a is equal to 4 by 2, implies that a is equal to 4 by 2, that is 2 meter per second square. We got the acceleration. Now mass somewhere is given, yes, 500 gram is given. So mass is equal to 0.5 kg and acceleration we just got now, which is equal to 2 meter per second square, implies that what is the force, and this is along y-axis we are taking, so force along y-axis is equal to ma, that is 0.5 multiplied by 2, this is half, so 1 Newton, but along y-axis, so 1 Newton along y-axis, this is the correct option. Clear?